everybody, this is Dr. Jacobs. This week we're going to learn about experimental design. We have a few unit learning objectives that we'll need to learn about while we're doing this unit. First, I want you to be able to define what a confounding variable is and describe how confounding variables are related to the internal experimental validity. I want you to be able to describe the post-test only design and the pre-test post-test, including the advantages and disadvantages of each design. I want you to be able to compare and contrast an independent groups, which is also known as between subjects design, with the repeated measures, which is also called a within subjects design. I want you to be able to summarize the advantages and disadvantages of using repeated measures design. I also want you to be able to explain how counterbalancing provides a way of addressing the order effects problems. And then last, I would like you to describe a matched pairs design, including reasons to use this design. So let's go ahead and get started. So we're going to start learning about experimental design. Whenever we're talking about research, this is the only design where we can examine cause and effect. And so a lot of times this is misapplied. Even our book constantly misapplies this by using other words that mean cause and effect. And they do it kind of wrong. So it's really important to pay attention to this lecture and making sure that when we're talking about studies that we're doing it accurately. So for experimental design, the researcher manipulates the independent variable to create groups. Okay, so all other variables are kept constant either through experimental control or randomization. So what this means is basically if we're doing some sort of intervention study, one group will get the intervention, one group will be our control and not get the active intervention. And we'll randomly assign participants to each of the conditions. Then we'll see if there are significant differences in the dependent variable between our groups. And so that's kind of a really basic thing. And so this is the only way that we can determine cause and effect. So experimental control, then, if we're going to take it a little bit further, means that we're keeping the conditions as the same as possible, except for whatever that treatment is. And so the book talked about having, like, if one room had windows and the other one didn't, if we're looking at mood, having windows might actually influence someone's mood. And so we would want to control for that whenever designing our study when possible. Randomization then means randomly assigning participants to the different conditions. So we don't just get to choose who goes in which group. We don't get to use pre-existing groups. For it to be a true experiment, which is another way of saying that we did experimental design, we have to make sure that we're randomly assigning the participants to the conditions. And so this is why a lot of times students really struggle, because they say, I want to know what causes abuse. And I'm like, ooh, hold up here. We have a little bit of a problem, right? We cannot randomly assign people to be abused, randomly assign participants to not be abused, and see if there's significant differences or things like that would even be right. So that would be effects of abuse, right? So if we wanted to look at what caused abuse, we'd have one group where we give them things that we think causes abuse. The other group, we have to keep them from those things that we think cause abuse. And then we'd see if there's higher rates of abuse in one group versus the other. And that's not ethical. We can't do that. We can look at those groups in a different type of design, but that is not cause and effect. That's just looking at significant differences. So in order to understand true experiments or experimental design, we might want to review independent variables and dependent variables a little bit. So the independent variable, it is often symbolized by IV. These are the different groups that we're testing. Specifically with experimental design, this is the thing that we're manipulating. And so whenever we hear the thing that the researcher manipulates, we're talking about if we're doing a treatment condition versus like some sort of placebo, that's the thing that we're manipulating. That's the thing that we're changing for our participants. Usually I just like to refer to it as the different groups because that's a lot easier to understand. But almost every book that you're going to read on research design will say it's the thing that you're manipulating. The number of groups that we have in an independent variable is also called the levels of the independent variable, and that is symbolized by K. So although in like a basic experimental design, you'll have just like a treatment condition and a placebo condition or a control condition, sometimes you might have more different groups, right? So you might have 3 levels to your independent variable. Say like I am a school teacher and I want to randomly assign students to be in one of 3 conditions. Students who don't do any extra reading at school, students who are encouraged to do 20 so the first group would be no additional reading outside of school being encouraged. The second group could be encouraging students to read silently outside of school for 20 minutes a day. And the third condition could be students that we encourage to read out loud for 20 minutes a day. And then we could compare if there's significant differences among the 3 different treatment groups or conditions. and see if there's significant differences in gains of reading level. And so in that study, if we randomly assign participants to be in each of these conditions, there would be k equals to 3, or there's 3 levels to the one independent variable, which is the reading condition. Our dependent variable is symbolized by dv. This is a thing that we're measuring. So in the previous example, when we were talking about reading groups, right? So the independent variable had 3 levels, the 3 different reading groups that we had. The dependent variable would be gains in reading level. Okay, and so we already had an entire lecture over measurement and how to evaluate whether a measure is a good one or not. So everyone in the study is measured on the same dependent variables. Some more advanced studies will have more than one. Just at this basic level, at an introductory research class, will typically just have one dependent variable, because when we learn about having multiple dependent variables, that's like your 5th level stats class that you're going to take. So in studies, the book kind of had this a little mixed up in like its organizational scheme, but something it did talk about, which is a threat to all the different types of studies, is something called attrition. Sometimes we'll hear this called mortality. And what this is when participants drop out of a study. And so that can be a problem, that can actually be a threat to the internal experimental validity of a study. And attrition is something that you have to report when you're doing your study and keep track of. If you have people who attrition out, sometimes we want to run statistics if we have information on demographics like race, ethnicity, gender identity, biological sex, different things, to see if certain groups are more likely to drop out of our study or not. But that is a more advanced kind of feature for it. So in this chapter, we also learned about confounding variables again. We had touched on this briefly before, but it revisited this. And a confounding variable is a variable that varies along with the independent variable. So good experimental design requires eliminating all possible confounding variables that could result in alternative explanations. So whenever we're designing our study, we want to make sure that we're controlling for things that could mess with our dependent variable. That way, when we are at the end, we can say, no, I really think that this independent variable caused this to happen. So studies demonstrate good internal experimental validity when we can attribute the results to the independent variable and to nothing else. So basic experiments, when we hear the word experiment, that actually means that we did a true experiment. In other words, that we employed experimental design. Remember, to do experimental design, you have to have that experimental control, and you also have to randomly assign your participants to the conditions. If you did not do that, you're not doing an experiment. Okay, so refer to research that fails to use experimental design as studies, not as experiments, because it is not an experiment. And there is a show that is on Netflix right now, and I believe it is called Love is Blind. I had to think about it for a minute, and they keep saying a social experiment. It's not an experiment. And every time I hear that, I'm like, not an experiment, not an experiment. That is a case study at best. Okay. So we need to work really hard for the only difference between the different groups to be this independent variable. And that takes a lot of thought. And with research, there is never a perfect study. In fact, I get so frustrated that I still make mistakes. I've been doing this for a really long time. And when I go, oh, man, I should have thought about this, or I should have done this. And a lot of times, like if you make one choice in designing a study, it's a positive for that, but it can be a drawback in other areas. So you have to end up using a lot of critical thinking skills to make this work. So one of the types of designs that the chapter went over was the post-test only design. And this is where we use 2 equivalent groups to avoid selection differences. So selection differences means that one group might be superior in the dependent variable to the other. One way that we can do this to try to get equivalent groups is by randomly assigning our participants to different conditions. That means typically we'll use a random number generator of some sort or a random number table to assign participants to different conditions. And to do this is called manipulating the independent variable, where we're randomly assigning the participants to go to each of the conditions that they're not in naturally occurring groups. And so then we'll measure the effect of the independent variable on the dependent variable. So we'll have these different groups and see if there's significant differences between the groups on the dependent variable after whatever condition or intervention that we employ. So some limitations to post-test only design is that we don't really know if our groups are equivalent at the start of the study. As we increase our sample size, when we randomly assign participants, it's more likely that they will be equivalent at the start. But if you have a really small sample size, that may not be the case. So some people might want to do a pre-test, post-test design. With experimental design, because you can use this in different ways as well. But for this, you have a pre-test that occurs before the intervention or the manipulation is started. You do it for both the control group and the intervention group. The intervention is provided, and then you have the participants take a post-test after the intervention is complete. Often we do find this design outside of experimental group design. A lot of times we'll see this with something called within group design. You've probably done this in classes before where you take a pre-test and a post-test to see if there's significant gains in your learning. One problem with this, though, is that the pre-test, post-test design can overestimate the effect of what's going on with the intervention. And so this is something that the book mentioned as an advantage. A lot of people would indicate that's actually a disadvantage because when we're doing that, if you do a regular effect size, if you remember from stats that just because we have significant results, it doesn't mean that those results are meaningful. So if we have significant results, we do an effect size of some sort, which tells us how meaningful those are. When we're using pre-test and post-test design, effect size actually overestimates the effect. So they can say there's a lot bigger differences than there actually are. So one way they get through this is by utilizing the Solomon 4-group design. And this is where you have 4 different groups that you have one group that's your experimental group, and they just take a post-test only. And you can compare that to a control group that has just the post-test only. You can compare those. You can compare experimental group and a control group who both take a pre-test and post-test. And then when you do this, you can also see if there's significant differences between the groups who just got the post-test only or the groups that took the pre-test and the post-test. And what this does is help us to estimate if the pre-test kind of sensitized people to taking the post-test. Sometimes if you've learned in neuroscience class, so there's something called the testing effect. And the more that you test on something, it might be just because you've been exposed to that test rather than the actual gains in your learning. So there's different ways that we can assign participants to conditions. There's something that's called independent groups design. Other names for this include between subjects design or between group design. If you had statistics with me, I typically call it between group design because that's just how I learned it. And this is where we have different participants in each level of the independent variable, or there's different participants in each group that we're comparing. In experimental design, we randomly assign participants to these conditions. With a repeated measures design, there's other names for this that include within subjects design, or like I call it within group design. They mean the same thing. And this is when we test the same participants multiple times. So you have the same participants in every level of the independent variable. So one repeated measures design, maybe we have some sort of intervention. So we do a pre-test, and then we want to measure the gains after. So we have a post-test, and then we could do a follow-up a year later and see if those differences still hold after a year or so. And all the same participants would be in each level or each condition. There's also something called order effects that we had to pay attention to when doing experimental design. And this is the order of presenting the treatments can affect the dependent variables sometimes. One type of this is the practice effect, which we kind of alluded to already. And this is the order effect where participants do better on the second task because they've been exposed to the first one. There's something called the fatigue effect, and this is the order effect when performance on the second worsens from the first because the participants get fatigued, so tired, bored, irritated. Then there's also something called the carryover effect. This is when the effect of the first task continues to influence the response of the next task. So the first task can prime you to respond a different way to something that you're exposed to later on. And so one way that we can deal with this is called counterbalancing. So complete counterbalancing is when all possible orders of presentation are included in the experiment. So if we were doing something where we were testing people on a math test and then a science test, half the participants could get the math test first and then the science test, and then half the participants would get the science test first and then the math test. And so if you just have 2 tasks that they're doing, it might not be too hard, but if you have a ton of them, that can be really problematic. And you can use something called the Latin square to control for order effects without having to have all possible orders. Another strategy that you can use is you can put time in between the intervals. So this could be including a break between the conditions to help mitigate some of the fatigue effects. So give people a break so they're not having to sustain their attention. And the amount of time between conditions also depends on what's being studied. So if you're doing some sort of pharmaceutical, you'd have to look at the half-life of the drug to make sure that the first drug is out of the system before trying a second. Another thing that you could do if it's something that relates to like cognitive abilities, you could provide an unrelated task in between to help work as like a palate cleanser of sorts. So to help the first task not carry over into the second one. And so there is another type of way that we can assign participants to conditions, and this one's a little bit more complicated. This one's called a matched pairs design. And sometimes you hear this referred to as a matched group design. So if you took stats with me, it's the same thing. And the goal is to first match people on a participant variable such as age before engaging in the manipulation. This is especially helpful with small sample sizes because the smaller sample size that we have, the less likely that our groups are equivalent to start. But this is a lot trickier than between group and within group designs. So the way that we would do this is we first measure the participants on whatever attribute. So if it's age, we get the age of all of our participants. Then we rank the participants in order from the greatest to the least. So we have our oldest participants all the way down to our youngest. So if there's two groups, let's say we're just assigning participants to two groups, we would take the two oldest and then randomly assign them to groups. We don't get to pick those groups. We randomly assign them using a number generator. Then we go to participants 3 and 4, the next two participants, and randomly assign those two groups. Then we continue through the entire sample until everybody is randomly assigned to a group, but it's based on their age, if that's the attribute that we're looking at. And so when we're looking at these different ways that we assign participants to groups, this aligns directly with what statistical analysis we would use to be able to analyze the data set that we have. All right, so that's what we have for this week. I hope you learned a lot and that this was helpful, and I hope your semester is going great. We're getting there for sure.